All right, morning everybody. It's Friday, May 8th, I think it's the date. Just wanted to let you know, tests are graded. I put the grades into Google Classroom. Remember, I'm just doing weekly averages on School Tool because of how they do or how they're doing grades right now. We still have not heard any information how final averages are going to be calculated, other than that marking period 4 is going to count somehow, some way. We just don't know anything other than that with that. Hopefully you guys are working on the lab. I've gotten a couple questions on that. If you have any questions, please don't hesitate to ask. I believe 5 weeks ends next week. I think it's the day for us, next Friday. And then we're going to start our unit on organic chemistry. This is a lot of, kind of practice stuff, and this is going to piggyback the test comments. Remember, we've talked a lot about, doing the work for knowledge and doing the work for a grade. You're going to want to do this for knowledge stuff, because if you ever do have to take anything in a higher level biology or higher level chemistry class, you're going to need this stuff. So please make sure that you go through and are doing the work yourselves. Questions are obviously fine to other students, but make sure you're doing it yourself. Today, I'm not going to give you the whole organic packet just because of how it lays out. You'll have the Edpuzzle notes. Obviously, you're doing them now if you're watching this. And then a hydrocarbon worksheet. This is all going to have to be handwritten out. It would be great if you could print the sheet and fill it in. It's just easier for me to look at it. But if you do not have the ability to print it, that's fine. Please make sure the paper you write on looks very similar in setup as the paper that I gave you, just because there's going to be things all over the place. Okay? All right, so we get going. Like I said, whenever we roll these questions on here, it's going to be quick on here because you can stop it or whatever, or I'll stop the video. Organic. What makes a compound organic? Simple answer to this is it contains carbon. All right. It's a compound that contains the element carbon and usually the element hydrogen. All right. There's very few exceptions to that. Like carbon dioxide, yeah, a lot of people think it's an organic compound. It's not, because it doesn't have hydrogen in it, and it doesn't come necessarily from something that was living. Why do I have a plastic bottle on the pictures for bell ringers in this unit? Is because plastic bottles are technically organic. They are made from oil, which is carbon compounds, so they're actually an organic compound. It's not what you would normally think of as like an organic food, like in the food section at a Wegmans or any other grocery store. Organic strictly means containing carbon, okay? All right, so we're going to get into some of the basic structures today when we get through this stuff. So introduction. All right, it's not the same as the organic section of Wegmans. Organic section of Wegmans talks about growing things naturally. All right, that's not what organic really means. Organic just means it contains carbon, which means it came from some type of living life form, because as we know right now, all life forms contain carbon. All right, chemistry research at this point in time, a lot of it focuses on organic compounds, either synthesizing or making new ones, or adjusting the ones that we already know. It's a huge field in chemistry. When you get to college, if you are a science major, other than physics, if you're like a life science major or a chemistry major, you're going to have to take organic. People want to be nurses and doctors and such. You're going to have to take organic chemistry. It's one of the hardest classes that you can take in college. All right, and this is just the bare basics for it. All right, originally comes from the meaning life. It's not just chemistry, it's chemistry of carbon and all different ways that carbon can be formed and arranged, and the properties that has as a result. Exceptions to things containing carbon that are not organic compounds, I said CO2 and carbon monoxide as well. And then there's things called carbonates or bicarbonates, like sodium bicarbonate, baking soda. Calcium carbonate is basically limestone. So those are the things that aren't really, they contain carbon, but they're not really organic. All right, carbon. Carbon is unique because it can make 4 bonds, all right, by sharing electrons. All right, remember, sharing electrons is a covalent compound or a covalent bond. So carbon compounds or organic compounds are by nature or covalently bonded. All right, they're called covalent. I jumped the gun there. All right, now there's 3 types of covalent bonds. We haven't talked about this, and the type depends upon how many electrons are shared between the 2 atoms. All right, if you share 1 pair of electrons, All right, you form what's called a single bond by sharing 2 electrons or 1 pair. Terminology we use is 1 pair, like a pair of shoes. You know, a pair of shoes has 2 sneakers. All right, if you have a bond, a double bond, all right, that's formed by sharing 2 pairs of electrons. 2 pairs of shoes would be 4 shoes, so it's 4 electrons. And then you can get a triple bond, all right, by sharing 3 pairs of electrons or 6 electrons. Now, if carbons need 4 bonds, all right, you can get that by having 4 single bonds. You can have 2 double bonds. You can have a double and 2 singles, or you can have a triple and a single. Is really the only way that a carbon atom can be, you know, we're looking for stability or happiness or a full valence shell of electrons. All right, and that's how it can be obtained that way. All right, why is carbon unique? It forms chains of carbons, and we'll talk about those chains today. We're going to talk about a group of them called hydrocarbons. All right, they kind of look like this. All right, you're going to see me put things up in front of you here. All right, this is a chain of carbons. All right, this is a 2-carbon chain that you see, the one that I'm holding in front of you. The one on the screen here is 1, 2, 3, 4, 5, 6, 7, 8 carbon chain. All right, the black spheres are always carbon in any model kit. And in this case, the white spheres are hydrogen. It's going to be the same as what I'm using here. Hydrogens are white. All right, and this molecule, even though it doesn't look straight, that's said to be a straight chain alkane or a straight chain hydrocarbon, because I can use like a finger or a pen and I can hit all the carbons without having to pick up and go someplace else. And we'll next lesson, not today, we'll talk about branched hydrocarbons, but today we're just gonna do straight chains. All right, other things that carbons can do, and they can make these funky shapes down here. All right, they can make ring structures. They can make ball structures, and then these super complicated organic molecules that can, you know, these are usually, you know, huge molecules that are, you know, this one, I honestly don't know what that one is off the top of my head. It's been a long time. But you get into like a lot of pharmaceuticals and things like that, or actually flavorings or smells and stuff like that as well. All right, so carbon can form a straight chain or these other things that, you know, we'll just call them, group them together as other things. All right, we have to get nomenclature down or naming down. All right, to be able to do that, we need to know prefixes for numbers 1 through 10. We usually have fun with this in class, but we really don't have the way to go back and forth on this, so we're just going to kind of roll through it. These are called organic prefixes. There's lots of prefixes that represent the number 1, but for organic, what they use or what has been used is the prefix meth. Like if you've heard of methane, all right, or methamphetamines, you know, your crystal meth people out there. Meth means 1 carbon. 2 carbons or 2 things means eth. So you can hear things like ethane or ethanol. If you've heard of ethanol, people have usually heard of ethanol. All right, 3 carbons is prop. All right, maybe you've heard of propane or propanone. Propanone is acetone. We've talked about that as being acetone. So you got meth, eth, prop, and these are things you really should know. All right, you're gonna go. You can look back at your notes. I understand that. You can look it up on Google, but these are things you're gonna have to want to know to be able to get through things in an efficient manner in this unit. Prefix for 4 is bute. That is not but. It's bute. So like butane or butanol. And then the prefixes 5 through 10 are just like any numbers that you've seen in geometry. Prefix for 5 is pent. Prefix for 6 is hex. 7 is hept. 8, most people know 8 is oct. 9 is non. And 10 is dec. All right, so you got meth, eth, prop, bute, pent, hex, hept, oct, non, and dec. All right, and these are prefixes. These are things that go in front of words, and usually we're going to talk about them going in front of, you know, whether it's carbons or other elements, or they're used to identify the number of carbons in an element or in a compound. All right, so we're going to talk about hydrocarbons. Hydrocarbons fall into 3 classes: alkanes, alkenes, and alkynes. Hydrocarbon. All right, this is a hydrocarbon. This is a hydrocarbon. Just like the name says, hydrocarbon has nothing to do with water. Hydrocarbon means it contains hydrogen and carbon. All right, so it's going to have 2 types of elements in there. All right, alkane, we'll talk about saturated once we get to the alkenes, but alkanes for right now, just write down they're the only saturated hydrocarbon. What it means is they're saturated with hydrogens, and it'll make more sense when we see what the double bonded ones are. As the number of carbons increase, the intermolecular forces increase. So remember, intermolecular force. That's a force between molecules. It's the force that holds them together. So if you increase the intermolecular force, it means it's going to have a higher boiling point, higher melting point. That's kind of what it means for organic chemistry. The bigger the molecules the more the number of carbons it has, the higher the boiling point, higher the melting point. So there we go. I jumped into the boiling point will increase as you increase the number of carbons. That's kind of like that's what we look at here. All right, and if you look here, we've got these things. The graph really doesn't mean anything for you. You don't have to write the graph down or anything. You got pentane, hexane, heptane, octane, nonane, and decane. Those are, 5 through 9, 5, 6, 7, 8, 9 carbons or 10 carbons. And you'll see that the relative boiling points increase. Okay, and that's really all, and that's due to the intermolecular forces. Think of hydrogen bonding as an intermolecular force. All right, this is a different type, different type of intermolecular force, but it acts in the same fashion. All right, so alkanes are saturated. All right, alkanes have a general formula, as do alkenes, as do alkynes. Alkanes' general formula is CnH2n plus 2. All right, where C represents carbon, N represents the number of carbons. And then if you know the number of carbons, you can predict the number of hydrogens. Or conversely, if you know the number of hydrogens, you know it's an alkane, you can predict the number of carbons, but that's not usually what we do. So for example, let's take the compound, let's take pentane. All right, ane means it's an alkane. It ends in ane. Pent means it has 5 carbons. So it has 5 carbons, so we put 5 in here for N. All right, then to figure out how many hydrogens it has, you put in 5 here for the N here. So 2 times 5 is 10 plus 2 is 12. So for any of these, you can figure out the hydrogens really, really quickly. If you have propane, all right, C3, then H is going to be 2 times 3 is 6 plus 2 is 8. All right, so C3H8. All right, alkanes always end in the ANE. All right. What that means is alkanes, as we get through this, alkanes are going to mean carbons are single bonded between the atoms. There's single bonds between them. So propane, normally I would give you time to try to draw this out. We'll just kind of go through it. Propane means 3 carbons. Ane means there's single bonds between those 3 carbon atoms. All right, so it's going to contain 3 carbons. And, if you want to predict the number of hydrogens, you put 3 in here for N. 2 times 3 is 6, plus 2 is 8 hydrogens. So it's going to have 8 hydrogens. Now, what you have to ultimately remember, we have to draw what's called structural formulas. And you have to remember that carbon always has 4 bonds. All right? So the molecular formula, if we were to put this together, molecular formula just means C something, H something. So in this case for propane, it's going to be C3H8. All right, which we kind of already figured out, so that's why it's coming in there. All right, then we're going to draw what's called the structural formula. We're going to actually draw out what the structure looks like. All right, so you're going to draw out the carbon. So what I recommend you do to do this, and this is just going to pop up with the structure, but to draw this, you're going to draw 3 carbons in a row. 1, 2, 3 carbons. You're going to put, because it's an ane, you're going to put a single bond between those carbons. All right, and then you're going to fill in, quote unquote, with H's so that each carbon has 4 bonds. All right, so, I click on it, look at it. So here's our 3 carbons. We put a single bond between them. And then what we have to do is we have to fill in with H's so that each carbon has the right number of bonds. So if I have a carbon-carbon, if you ignore the H's here, if I look at carbon-carbon-carbon, all right, this first carbon has 1 bond with another carbon. So that means it needs 3 H's on it. That's where we get the 3 H's around. All right, this carbon has 2 bonds with carbon, so it only needs 2 H's. And then this carbon, the right carbon here, it has only 1 bond to another carbon, so it needs 3 H's. So the H's on the outside in this molecule are called terminal carbons. All right, they are on the beginning or the end carbon. All right, and they're going to have terminal carbons in an alkane have 3 hydrogens on them. All right, non-terminal carbons or carbons in the middle have 2 H's on them. We can condense this formula and write this as CH3, CH2, CH3. All right, try to give you a lot of scenarios that we can do here. All right, so what I'm going to ask you to do down here is to name that compound. I will stop the video and give you a question on this, but right now, all right, name the compound. So you've got 5 carbons, 1, 2, 3, 4, 5. They are all single bonds between them. 5 carbons means prefix of 5, which is pent. All right, they're all single bonds, so it ends in ane, so it's pentane. All right, if we wanted to get the molecular formula, it would be C5, and then H, you can either count up the H's, you'll count up 12 H's, or you can go 2 times 5 is 10 plus 2 is 12, so C5H12. All right, so that molecule is pentane. Okay, alkenes. So alkanes is that one type of hydrocarbon. Alkenes is another. Alkynes is the third. All right, they are all hydrocarbons. They're all compounds that only contain carbon and hydrogen. General formula of alkenes is CnH2n. So here, the only difference between alkenes and alkanes is that they've lost 2 hydrogens, and that's due to alkenes have a double bond. All right, the naming for alkenes always end in ene. So if you see the name ene, all right, you know it's a compound that's got a double bond someplace. All right, so we're going to deal with ethene. All right, ethene. How many carbons does ethene have? Eth is prefix for 2. Ene means there's a double bond. All right, so this contains 2 carbons and 4 hydrogens. So when we do this, so the molecular formula, if you're going to figure out the molecular formula, it's CnH2n, so it's C2H4. All right, now we got to draw out the structure of it. So what you're going to do here, I'm just trying to do a model here on the side. You're going to have 2 carbon atoms. So here we go, we got 2 carbon atoms. All right, we know it's an ene, so we know it has a double bond. It only has 2 carbon atoms in it, so we're going to put a double bond between the 2 carbon atoms. So when I do that, I put a double bond here. All right, so this signifies a double bond. You got 2 lines between the 2. All right, now we need to get 4 hydrogens. So we need to get 4 of these things. This is one of them. All right, onto here, and I know it's hard to see on here, but this carbon here has 2 holes or 2 spaces for hydrogen. So I put a hydrogen here and a hydrogen there. And it's still got the double bond on the other side. And then I'm going to do the same thing on the other carbon because all carbons are the same. They all have 4. They all want 4. So I'm going to put another hydrogen over here. And you end up with this as your actual structural formula. All right, now we have to draw this. All right, and we have to draw it kind of. So what we do to draw it is we take 2 carbons and we put a double bond between them. All right, and then you put your H's off. Now, where the H's go for our level of chemistry doesn't matter. You'll see that they actually look like this. They'll actually space out. Remember, these are electrons. These bonds, these little sticks represent electrons. So electrons don't like to be near each other, so they spread out as much as possible. They really don't look like this, but we draw them like this just to make life easy. All right, because it has a double bond between the carbon atom, this is said to be an unsaturated molecule. It's unsaturated with hydrogens. What that means is we could actually break this bond and add hydrogens in here and here. All right, but as such, this is an unsaturated molecule. I forgot to show you this one on the last one. If you look here, this molecule here is what? It's got 3 carbons. It's got 8 hydrogens, so it's got to be propane. All right, and this is saturated. This has as many hydrogens as it possibly can. There's no place to add any more hydrogen, so it's saturated with hydrogens. This molecule is unsaturated because it has a double bond. Okay? All right. So name the following. So here we go. Boom, pause in the video. All right, but I will not do that here. To name this, you have count up the carbons. You got 4 carbons. You've got a double bond. We have to actually identify where the double bond is. All right, by a number. This is actually 2-butene. See if I can make 2-butene pretty quickly here. I think I can. Of course I took the stick off. Spheres dropping all over the place. I'm sure you can hear it. All right, so I just made 2-butene. So right here, oops, I forgot to put a hydrogen back on here. There we go, now we're good. So this is what 2-butene looks like in the real world, so to speak. All right, you got 1, 2, 3, 4. Off the second carbon, there's a double bond. All right, would this be considered a saturated or unsaturated molecule? It's unsaturated because it's got a double bond here. Now, all butenes are not the same. And that's why we have the number 2 here. The number 2 just tells you what carbon the double bond is after. All right, what if I do the following? If I take this, I'm going to take it off screen, it's easier. So here we go. All right, we got it. So now we've got this one. Still got 4 carbons, still got 8 hydrogens. All right, just oriented differently. All right, now the double bond is here versus in the middle. And what this does is it changes the molecule. This is now what we call 1-butene. You could also look at it this way and count it as 3-butene because it's after the 3rd carbon, the double bond. All right, if after this side it's the 1 carbon, that's the double bond. The rule is, for the naming rule is, you always have to pick it from the side that's the lowest number, because in the real world, this molecule and this molecule are the same thing, so they can't have different names. So we have to name them uniformly. So this is 1-butene. 2-butene is when the double bond's after the 2nd carbon. Okay? All right, so that's alkanes and alkenes. Now we're going to do alkynes. Maybe you can mathematically predict what the formula for alkynes are going to be. Alkanes were CnH2n plus 2. Alkenes were CnH2n. So alkynes are going to be CnH2n minus 2. Okay? Name always ends in YNE. It's pronounced like an I, so it's pronounced ein. So we're going to have you, at this point, I would give you time to draw out 1-pentyne, all right, or predict what 1-pentyne is. How many carbons does pentyne have? All right, it's got pent, so it's going to have 5 carbons. All right, and then hydrogens, we plug in a 5 here. It's 5 times 2 is 10 minus 2 is, so 10 minus 2 is 8 hydrogens. All right, and the molecular formula is going to be C5H8. We already figured that out. And then the structural formula, we have to draw it. So now you got to draw it. So I'm going to give you time, boom, draw it. I'm going to do a model real quick of it-ish. All right, so when you draw it out, you're going to get something like this. Triple bond, you have a triple bond in there. Once again, where that triple bond is makes a difference. I'm not going to put in the hydrogens on this molecule because I actually didn't have enough in my kit. I don't want to take time to go through and take apart all the other ones. All right, so here, this is at the end of all these other sticks, there's going to be a hydrogen there. All right, so just imagine that there's hydrogen there. This is, you've got 1, 2, 3, 4, 5 carbons. 1, 2, 3, 4, 5 carbons. We're good. All right, and then notice that the terminal carbon here only has 1 hydrogen off it because it's got the triple bond here, because it's got 3 other bonds taken up with the carbon, so it only can have 1. This carbon, the unique thing in alkynes, the interior carbons have no hydrogens on them because there's no space for that. All right, now naming this, what do you think you would name this as? All right, remember this molecule is the same as this molecule. All right, so we have to name it appropriately so they both have the same name. This has only, the triple bond's only after the 1st carbon, so then we call this 1-pentyne. All right, it's an unsaturated molecule. All right, so this thing is called 1-pentyne. I don't have the name up on here. All right, now if we were to take this carbon off down here and put it down here, all right, now we have, it's still pentyne. All right, but now we have 2-pentyne because that double bond's after the 2nd carbon, whether you look at it from this perspective or that perspective. All right, what if we try to move it down to here, change it again, you still have after the 2nd carbon, so you can only get 1-pentyne or 2-pentyne if you're only changing the ions or the location there. All right, so real quickly, you're going to name this one. I'll pause it. You'll pause it. And the name of that compound is 1, 2, 3, 4, so it's bute, and it's triple bond, so it's ein. Is it 1-butyne or 2-butyne? It is 1-butyne. Okay, all right. I'm gonna pop these up here just so that you guys can get practice to do it. I'll pause it and say draw it out. All right, octane, get practice drawing it. It's gonna have 8 carbons with all the hydrogens. 1 hexyne is going to be 1, 2, 3, 4, 5, 6. Triple bonds after either this carbon or that carbon, it doesn't matter. Propene, double bond, 3 carbons, doesn't matter where you put the double bond between the carbons. And then you've got 2-pentene. You had to name this one down here. Okay? All right, that's it. Numbering carbons we already talked about, so we are good with that. Okay, all right, so please do the worksheet. It's the only, you've got to get practice on this. All right? Okay, we'll talk to you later. Bye.